Hey everybody, this is JC here. I'm just here to show you the setup for the project that I did. So let's just get right to it. So this is the Analog Discovery 2. I have it connected to the LDC1000EVM. These are the metals that we're going to sense on the EVM. Everything is explained in the tutorial that I created. Like I mentioned, we are using a power supply, but we could also use a voltage regulator, which is mentioned in the EVM, so that we don't have to have these extra wires here and just use this device only. So we will go to the software. We have the waveform generator here, and this is how it's set up. We have the protocol analyzer, which is the main code that we'll be using to send signals to the EVM and receive information from it. We have our power supply voltages, we have our logic analyzer will give us a digital output, and then we have our scope. So we will start running everything. So we turn on our power supply, we turn on the wave gen power supply here, the logic analyzer, and the scope is armed and ready to go. So in this first time we're just going to run it. So execute and look at the scope. We get our output. We can see how the signal changes as we put metal. So I just had it for 1 second. So we could look at the output of the logic analyzer, and we could see that the data has changed accordingly. Let me just bring this across. So we're reading information from the sensor, and we're getting different sensor data out of it. And we have multiple different buffers to catch the trigger of the chip select bit, so we can catch the information being sent out and the information that we're receiving back. The other cool thing that I wanted to show is if we put everything back, let's just clear the buffers here, and then we run the logic analyzer and the scope. We could actually use the debug option, which is here, and step by step within the code. So we'll just click on the wait. We could run the debugger. Let's click on the scope. We could see the scope in the background, as well as the logic analyzer waiting. And then we could put the metal on top. We could see how the signal changes. So this is aluminum, this is steel, this is brass, and this is copper. So I hope this helps you guys out. Very useful tool for analyzing this instead of using a microcontroller, and thanks for watching.